In this video, we are going to finish up the section covering solving trig equations. I'm going to show you one more technique here to get out from the 2x there, cosine of 2x on our first example, and then show you a quote-unquote real-life problem using right triangle trig. Okay, so I see that cosine 2x. I know that causes an issue. I don't really, actually, I'm going to show you a different way. I was actually going to take a different route. Let me show you how I would go about this. Okay, so I have that. And then here's when I see that 2x, I got to be kind of careful. There are ways around it, but what I'm going to do is we're going to say that is 0 to 2 pi, and it's not or equal to, it's just less than. So that's what they want my answers on, but this isn't what that says. It doesn't say find cosine when cosine's 1/2 when x is in between that. It says 2x. So if I were to change this, I'm just multiplying the middle by 2, which means I'm going to multiply the outsides by 2. So this tells me instead of finding 0 to 2 pi, I'm going to find 0 to 4 pi. All right, so this is kind of what that paragraph is saying. Now I'm going to find those. We could change this to an identity and work it out, but I'm not going to. I want to show you this route just in case you can't do that. Okay, so we have 0 to 4 pi. I'm going to find all those, and what I'm going to do is call them 2x now. So I need when is cosine 1/2. So if I'm thinking about it with my triangles, okay, cosine 1/2, cosine's x, and 1/2 is the small side, so that's got to be my tall triangle. So one answer for this would be pi over 3, right? And then I know that I want the cosine, so it's going to be the angle down here because this is when cosine is the same right there. It's not different. And if that's a pi over 3, this is a 6 pi over 3 when it's all the way around, meaning that's a 5 pi over 3 going backwards. So I get two equations here. 2x equals pi over 3 and 2x equals 5 pi over 3. But I got to keep going because they want not 2 revolutions, oops, not 2 revolutions here, but 4 for the one that we're doing. So let me scoot these over. Forgive me. So the next one, I'm just going to add a full 6 pi over 3 to the first solution. So that gives me a 7 pi over 3 landing in that same spot. And then 2x here, I'm going to also add 6 pi over 3 to that one, giving me 11 pi over 3. Now notice that all solutions here are actually between 0 and 2 pi. But not everything is equal to 2x. It was actually equal to this 2x. But now if I divide everything by 2, pi over 3 divided by 2 is pi over 6. 5 pi over 3 divided by 2 is 5 pi over 6. The next one's going to be a 7 pi over 6 dividing by 2. And the last one is 11 pi over 6. Now, if you were to look at all four of these answers, all four of these answers are between 0 and 2 pi. What actually helps when you plug it in is that 2 here is going to knock it down um, or move it back up rather. It's going to times it by 2, moving it back to the actual answers. So that's how you do it. If there's multiple, you can split them, make the argument or the interval requested bigger, and then take it back in the very end. Okay, our last one here is kind of a silly problem, but I want to show you how to use it. All right, OSHA safety regulations require that a base of a ladder be placed 1 foot from the wall for every 4 feet of ladder length. Find the angle that a ladder of a length forms with the ground and the height at which the ladder touches the wall. So notice that it says what they said OSHA was that for every 1 foot here, we're going to have 4 times that there. So that's why we have A, and then you just times it by 4 to get that length. And then what they're wanting to do is find the angle theta of the ladder for any length that forms with the ground at which the ladder touches. So since that ratio is going to hold 4A over A, 4A and A is going to be the same every time, that theta should hold. That's trig, right? So with that, we're going to write a ratio here. So if you notice from theta, that is our cosine. So cosine of theta is equal to adjacent over hypotenuse. And that means cosine theta is equal to 1 over 4. Right, and then 1/4 is not on our unit circle. So I'm going to do an inverse cosine to figure that out. Inverse cosine of 1 over 4. And that's going to also be approximate because I'm going to round it. So inverse, and then probably dealing with OSHA. We're probably going to be dealing with degrees. So I'm going to go over to degrees and now do my inverse cosine of 1 divided by 4, we could have done 0.25, and I get that angle is going to be 75.5 degrees. Now, normally we would have to go through and find the other one, but obviously it's not going to be that other cosine that's usually down here. We're not going to have an angle for a ladder to be that big angle there. So it makes sense just to have the 75.5 degrees. All right, that's it.